tRPC has a convenient section in its documentation to talk about using tRPC with TANStack query. So if you just go under client usage here, you'll see TANStack React query right on top. We can go to setup and get started. But I'm only going to be loosely following the documentation here. I personally don't think that this documentation is really that clear in how to set it up. A lot of the information's jumbled between different pages. So I'm going to go really slowly, just follow what I do, and we'll all be able to use tRPC and TANStack query together. To start off, we're going to have to first install the dependencies. There's no helpful copy button here, so we're going to have to select over all the dependencies that we want to install, hit Control-C to copy it. Then we can go over to our IDE and in our terminal, paste it all in. Now, they didn't include some of the packages that even in their own documentation, they are recommending us to use. And so I'm going to install it all here instead of when we start using it, just so that we don't forget anything and run into some issues later. So first, we have Zod, then client only, server only, and lastly, super JSON. Remember that since we're using NPM, we're going to need to use --. So let me zoom it in so that we can see everything on the same page. Why don't we push it over a little bit? There you go. So make sure that you have all of the same dependencies. NPM install tRPC server, client, TANStack React query belonging to tRPC, TANStack React query itself, Zod, client only, server only, super JSON --. It's a lot of them, so that's why I wanted to go over it. Make sure that you have all of them, and they should install relatively easy. Great. Now let's move on to setting up the file structure for our tRPC implementation. Great. So for the file structure, we can open up source here, and at the source level, we can create a new folder called tRPC. And inside of tRPC, we're going to have the two sides of a full stack app. We're going to have client, and we're going to have server. tRPC generally doesn't deal with this client side, but this is just to delineate these are going to be used in client components. These are going to be used in server components. So I know that there's a bunch of different ways in which people kind of set up their tRPC file structure. This is the one that makes the most sense for me. You're welcome to do whatever works for you. All the files should be the same. It's just how you organize it. The imports might be a little bit different, but in modern IDEs like VS Code, all the imports should work automatically, so not too much of a worry there. So use whichever file structure feels most comfortable for you. I'm using the one that has worked out really well for me. Let's start on the server side here. We're going to create a new file, init.ts, and inside of here, we're going to start with creating our tRPC context. So we're going to create a method, create tRPC context, and it's going to use the cache from React, and although we're going to be passing into our cache is an arrow function, which will return DB, our database object from @/DB. Great. Next, we're going to have to create a type for our context, which easily enough will be DB type of DB. Right? So if you hover over a context, you can see I don't want to rewrite all of that, so I'll just use type of DB. After that, we are going to initialize our tRPC instance. So we're going to do that by init tRPC. Looks like it's not auto importing, so we're going to need to do import init tRPC from @tRPC server. There we go. And then after that, we're going to need to do dot context. And we're going to pass in our context type. And then invoke the create method. And for our data transformer, we're going to use super JSON. And let's import that. So let's go and reorder things actually. Straight from the top here, import super JSON from super JSON. So the primary reason for using SuperJSON is that when we make our API calls via tRPC and even Hano or a lot of other types of RPCs, dates become a big issue. There's random configuration errors that happen underneath the hood somehow, so that when dates get passed, they turn into strings, and if you're expecting a date object, you're going to have a mismatch. Using SuperJSON, you don't have that automatic conversion happen underneath the hood. You don't have to worry about that, and there are many other different cases that SuperJSON helps you out. So I would just recommend using it. If you're vehemently against it, then you're going to have to remember to, I'm going to call it, normalize your date objects, or normalize date strings into date objects if you use them in that manner in your code. If you're using Drizzle like I am, and you're using the types that are inherent to Drizzle, usually those types are going to be based off of date objects as opposed to date strings. And so you're going to have to be able to do those conversions. I don't want to deal with that, so I'm going to use SuperJSON. Next, we're going to create some base router and procedure helpers. And so we're going to first start off with create tRPC router is equal to t.router. And so that's what we'll use to create any routers that we're going to be using. You'll see what a router looks like specifically in a second. Export const create caller factory. This will allow for us to create server instances. So as you can see here, create a server-side caller for a router. Great. And you can create a base procedure here. A base procedure is one that does not use any middleware. So we can have full control over our process and not use one that has a bunch of our boilerplate in it. To show you an example of one that has this middleware, we're going to create a protected procedure which has a authorization check inherent to it. So a base procedure which you can use for any public API calls that are unauthorized. Protected procedures will only be allowed to go through for authorized users. That's just one of the use cases between having base procedures and these protected procedures. So we're going to do t.procedure.use t.middleware here. And then inside of here, we're going to pass in an asynchronous function. And the reason that it's asynchronous is, if you remember, authorization was an authorization check is asynchronous. So we're going to do const session is equal to await get session from @/lib auth. Then we can do the same unauthorized check. So if not session, then we're going to throw new tRPC error from @tRPC/server. So there we go. It takes in an object. We're going to provide a code here, which will be unauthorized. Great. Sorry, it's not an equal sign. It is a colon. There we go. So we can provide that error message. We're in an API, so instead of doing a redirect, we're doing a error message that we will return as a response to the user, so they can handle the error in their front end in any way that they'd like. And then we're having this little error here because we need to return next here. And then we're going to provide context. And I'd like to add in something extra, not just use the DB instance that we can use inside of our API call. We can also use user session.user, so we can provide the current user information into our context, and then we can spread the old context in. So if we had more things inside of this initial context than just DB, we'll be able to use the spread operator here to add all of them to this new context object that also includes our user. So great. When we look at this initial context type here that gets added to our initial tRPC instance, it only has this DB. We don't have access to the session until this middleware is invoked at the start of our API call. So thus, that's why we're not including this user inside of this context type. So hopefully this gives you a little impression on how some parts of tRPC works. Since we have this method create tRPC router now, let's create our app router that's going to hold all of the rest of our routes, which in turn hold all of the procedures of our application. We can start to do that by going over to server here and creating a new folder called routers. And inside of this newly created folder, we're going to add in app.ts. And inside of here, we're going to add an export const app router. And it's going to use create tRPC router from /init there. Great. And inside of here, it's going to store all of our routers. For now, we'll just pass in an empty object. Once we create our routers, we'll need to remember to add them here so that they can be used with the rest of our project. Then we're going to export type app router, which will be type of app router. So this will allow for tRPC to know what the shape of our router is, what all of the internal procedures look like. Great. Next, we're going to need to create the tRPC instance that we can actually import and use inside of our server components. We can do that by going to the server directory here and creating a new file, index.ts. When we try to use something inside of this index.ts, the file path will be trpc/server with this index.ts. It just goes back to look like server.ts. We're not going to be importing anything from init.ts outside of tRPC, so we won't have to worry about that. So that's why we can put these things in index.ts and allow for the file path to look a little bit neater in some of those imports. The first import for index.ts here will be importing server only. The reason that we're importing this is to ensure that this file cannot be imported by anything on the client. So if there's any use client on the top declaring something to be a client component, then it's going to have an error if it's importing something from this file. Next, we're going to need to import cache from React. Then we're going to import our app router from /routers/_app. So sometimes you'll see me in components turn these into @/components, whatever. The reason that I do that is because if you move something, then it might re-trigger a change in your file structure, and then VS Code sometimes, or Cursor or Windsurf, sometimes does like // to try to get to that right directory, but that looks really ugly. So that's why I use that alias @ to get around that. But I'm never really going to be moving index.ts, so I'm totally cool with this / notation. Hopefully that helps you understand why I'm allowing it this time. Next, we're going to import create tRPC context from /init. Okay, we're going to create export const get query client cache here, and we don't have this yet. We're going to create it in a second, but we're going to need to make some form of query client. This belongs to this will allow us to manage the state of the various queries that we're making and modify it. Let's say that we use a mutation and change something in our database. We would want to refresh all of our queries so that we can get all of the new data from our database and declare our old queries stale so they can get rid of the old, potentially out-of-date data. This is what the query client allows us to do. We haven't set up the client side yet, so we don't have it, but once we do, we'll go back and make sure that we have it imported. Moving on, we're going to create the exportable instance here to create tRPC options proxy. So we're not easily able to extract it. So we're going to need to import create tRPC options proxy, and this will be gotten from at tRPC/tanstack react query. Great. And this is a method which will take in context, which will be create tRPC context, router, which will be app router, and query client, which will be get query client. Okay. Whoops, I forgot. We need to wrap these in parentheses if we're going to return it, so there's no more error here. So good. I think that we're all set with this file. Then we can move on to the client side, make sure that we have make query client here, but also to have the same callable tRPC instance on the client side as well. Let's jump into it.